How we can use the GDC to find the area between a curve and the x-axis, where part of the area is above the x-axis and part of the area is below. So if we were to calculate that all in one go, we'd have a problem, because part of it would be counted as being positive, part of it as being negative, and the positive and negative would basically cancel each other out, so we wouldn't get the true area. So let's have a look through this example. Find the area between the curve y equals e to the negative 2x plus x squared subtract 5, and the x-axis between x is equal to 1 and x is equal to 3. So I've got that graphed here. That's the e to the negative 2x plus x squared minus 5. And I know that I'm going to be trying to find the area between x is equal to 1, so down to here, and x is equal to 3, so up to here. And I can see from that then this bit here would be calculated as being negative, and this bit here would be calculated as being positive. So the only way that I can get the true area is to calculate the two of those separately. So the way that I can do that is, first of all, I need to know where this point here is. I need to know where it crosses over from being negative to being positive. So I'll go Menu, Analyze Graph, and 0. So click on the left, click on the right, and I've got then my 0 position as being 2.23. Now I can do my areas. So I've got my Analyze Graph, Integral. I'm going to do the lower bounds this time round as being 1. Enter. And then I'm going to click on the intersection point to make sure that my upper bound is correct. So that gives me an area of negative 2.72. I'll do the same again. Menu, Analyze Graph, Integral, click on the intersection point to be my lower limit, and then I could just type in 3 to make sure it goes exactly to my upper limit, and I get 1.46. So what I could now do is take those values, obviously make the negative one positive, and add the two together. So ultimately that will then give me the true area. So 1.46, add 2.72 gives me my area of 4.18. Now there is an easier way potentially that we can actually do this on the GDC, because there is a way that we can make this graph so that the areas are always going to be positive. Let's have a look at doing that. So I'll change this graph now. What I'm going to do is I'm going to insert a modulus symbol. So the modulus symbol, choose from this menu here, the modulus symbol is this one down here. I use the modulus symbol, and I'll just copy and paste this into the relevant spots. I'll put it into here instead. Then what that does is every time a result comes out as being negative, it switches it to becoming positive. So if I press enter, you'll see the effect this has on the graph. Basically spins it so that as soon as it falls, as soon as it drops below the x-axis, it becomes positive instead. And now what I'm able to do, let's get rid of these areas that I've already calculated. So I'll get rid of this one here. Now what I'm able to do is basically calculate that area all in one go, because it's all above the x-axis. So if I go Analyze Graph, and then go Integral, and just type in now my 1 and my 3, then it gives me the 4.18 that I calculated before, but it's calculated it all in one go because I didn't have to worry about any of the area being below the x-axis.